So in this video, we're going to be looking at coterminal as well as reference angles. But first, let's look at coterminal. So coterminal angles are angles in standard position with the same terminal side. So let's look at that. In this picture, we have a 90-degree angle going that way, and then we also have this angle of negative 270 degrees. See how they're going in different directions, but they ultimately come to the same terminal side, which would be this ray right here. That is the terminal side. We talked about this in one of the previous videos. So, since they do go in different directions, but they ultimately come from the same initial side to the same terminal side, these are coterminal angles. So, what if we are just given a degree, like we are given here in 65? If I want to find its coterminal angle, then I'm just going to add and subtract 360. So 65 plus 360 is going to give me 425 degrees. So that's our first answer. And now I'm going to subtract 360. So 65 minus 360 would get me negative 295 degrees. So this would be an example of a positive coterminal angle, and this is an example of a negative coterminal angle. And if you look at the directions, they want us to give a positive and a negative. So that's perfect. Let's look at the next one, 540 degrees. So since 540 is already larger than 360, I'm going to start off by subtracting. So 540 minus 360. You type that in, and you're going to end up getting 180. So that would be an example of a positive. But note, if I were to add 540 and 360, I would end up getting another coterminal angle that's positive, which isn't a bad thing. Like if you had to list multiple coterminal angles, you could do this, but I want a negative one. So let me erase this. And what we're actually going to do is, since 180 is coterminal to 540, I'm actually just going to take the 180 and subtract it from 360. And that'll give me a negative coterminal angle. So we have 180 minus 360. And when you do that, you end up getting negative 180. So there we go. Here is a positive coterminal angle and a negative one. Well, what if our angle is given in radians, like it is for 12 and 13? When it's in radians, you're actually going to add or subtract by 2 pi. So actually, let me make a note of that. So if it's in degrees, like it was in the last problems, you're going to add or subtract by 360. But if it's in radians, then you are going to add or subtract 2 pi. So let's do that for number 12. So we're going to have 13 pi over 18 plus 2 pi. So when adding these together, I'm going to say don't even worry about the pi's. So say we just scratched out pi, like it's not even there. So type in your calculator 13 over 18 plus 2. And then when you do that, you're going to end up getting 49 over 18. And now we have to worry about the pi, so just tack it in right there next to the 49. So that's how you would go about doing this. You would just go ahead and add the numbers together first, and then add the pi at the end. So this would be a positive coterminal angle, 49 pi over 18. Well, now let's subtract 2 pi. So we have 13 pi over 18 minus 2 pi. Same thing, like type 13 over 18 into your calculator, type that fraction, and then subtract that by 2. And you're going to end up getting negative 23 over 18. And just like in the last problem, get the number first, and then add the pi to the top of the fraction. And then this is a negative coterminal angle. Let's do one more. We have 14 pi over 9. So we're going to go ahead and add the 2 pi. So you're going to type 14 over 9 into your calculator and then add 2. And that's going to get you 32 over 9. And then once again, you need to add the pi at the end. So then your final answer is 32 pi over 9. So this is our positive coterminal angle. And last but not least, we subtract. So 14 pi divided by 9 minus 2 pi. Do 14 over 9 minus 2, and you're going to end up getting negative 4 over 9, and then you got to add the pi in there. So negative 4 pi over 9. Those are the positive and negative coterminal angles. So now let's look at reference angles. So a reference angle is an angle theta that's in standard form, so we're starting at this initial ray. The reference angle is the positive acute angle that is formed by the terminal side and the x-axis. So if this is our terminal side and this is the angle that's being opened up, the reference angle is the angle created by our x-axis going this way and our terminal side right here. Let me do that in a different color. Let's do it in pink. There we go. So it would be this angle right here in between the terminal side and the x-axis, and it can go pretty much in either direction. So let's do a few examples here. So for 225 degrees, let's start by just drawing that onto the surface. So let's see, we're going to go from about 90, 180, and 225 is going to stop roughly somewhere in quadrant 3. So we'll go ahead and draw that. So that's going to be 225 degrees. Put that in green. And now for the reference angle, we need to find what's going to be the positive angle. And keep in mind it says acute. Acute means that it is less than 90 degrees. So acute is less than 90 degrees. So then we're definitely not going to be looking at this space. We're not looking at this space, but instead we're going to be looking at this space, which is right here in between the x-axis and that terminal side, since this is also the initial side. So what we're going to do here is just do 180, or let me start the other way. You're supposed to do 225 minus 180, because remember, you want to keep it positive. So take the original angle and subtract it from 180. So when you do that, you end up getting 45 degrees. And that is the reference angle. Well, now what if we have negative 310 degrees? Well, we're going to be starting from here. This is our initial side, but now we're going this way. So we're going to go 90, 180, and almost 360, but it's going to stop roughly about there. So our angle, well, it's supposed to come out from the origin. It's supposed to be like that. So please ignore that little scribble sticking out. So this is going to be negative 310 degrees. And remember, we want the angle that's going to be less than 90 degrees, but also still partially connected to the x-axis. So we don't want any of this, we just want this. So for that one, we're actually going to be so now in number 15, since we have a negative number here, we're actually going to add 180. So I'm going to go down here with negative 310 plus 180. But notice, you end up getting negative 130. That's not positive, and it's not acute. So add 180 again. So negative 310 plus 180. Or, whoops, I wrote the same thing twice. What you should put is negative 130 plus 180. That's what you should write. And then when you type that in the calculator, you end up getting 50 degrees. And that is positive and it's acute, which is exactly what we want. So that is going to be my reference angle. So now let's do this last one, where we have 2 pi over 3. And this one is actually in radians. So what I suggest is go from radians to degrees. And you should know how to do that. And when you solve from radians to degrees, you should get 120. So let's go ahead and draw that. We're starting from the initial side, and it's positive, so we're going to go this way. And we're going to end up in the second quadrant. So this is roughly 120 degrees. So what we're going to do here is, since we want this positive space right here, is just do 180 minus 120. Since the 120 is positive, we're subtracting again. So we're going to have 180 minus 120. And when you do that, you end up getting 60 degrees. And then now, since our original problem was in radians, we want to put it back in radians. So we got 60 degrees. And then you're going to take the 60 and multiply it by pi over 180. And then when you do that, you end up getting your final answer of pi over 3. And pi over 3 is your positive reference angle.